Hey everybody, it's Mr. Roy. I'm here to give you a trigonometry unit review so that we can get ready for the end of our trigonometry unit. I hope this will give you a quick overview of the key ideas from this unit. And there's also going to be a series of I can statements which you should check yourself to see if you can do all of the things I'm going to mention in this video to help you be successful. Okay, so here we go. Let's start by just talking about our content. We said that we're going to be looking, and this is what thing you saw in class, we're looking at similar triangles, basic trig, sine law, cos law, and problem solving with trigonometry. Of course, at the beginning of class, we've got 30 minutes of review, practice, and getting help, 90 minutes of test time, and some assignment introduction. Let's jump in with our first topic. We're looking at similar triangles. This is the first one that we looked at in this set. So can you do the following things? If you can, that means you're ready for similar triangles. So our first one is tell when triangles are similar. To do that, all angles would have to be the same, or our matching side pairs would have to have the same scale factor, meaning to go from one triangle to the next, the matching sides would be multiplied by the exact same number. Okay, so do we have the same scale factor for matching sides, or do we have identical angles? Those would be our two criteria for similar triangles. So can you tell that? Can you set two ratios equal to one another to form a proportion? And can you solve for an unknown in a proportion by doing our cross multiply and then dividing to get our final answer? Okay, so on the left here, you're going to see our two examples of when we know we've got similar triangles. So the top one here, we have all angles being equal to one another, so the matching angles are equal. And the one on the bottom here, we have a scale factor. They say the same ratio, but scale factor means the same thing. So we've got a scale factor of 0.7. To go from one triangle to the other, we have to multiply each of the sides by 0.7. And they all have that same scale factor, meaning it's a similar triangle. Here's an example of a problem that you might run into, similar to one that we've seen on our assignments. So the question is, it says A and B and C and D are parallel lines. What's the length of BE? So we know since they're parallel lines and we know our opposite angle theorem, all the angles are identical. And that means we've got two similar triangles. And when we're matching up our sides here, I'm going to get out my highlighter and we'll see that this side here is going to match up with the corresponding side over here on the other triangle. And this side right here is going to match with our corresponding side over here. And if we wanted to look at the ends, which we don't in this particular problem, this side here would match up with this side here. Okay, so let's try this out and see if we can solve for the particular thing we want to know in question. What's the length of BE? So that's this top line right along here. Okay, so here's what we're going to do. We're going to set up our ratios, and first I'm going to say, let's look at my yellow ones I've marked in yellow. I'll look at my smaller triangle first and say that side has a length of 2, and the equivalent one on the other triangle has a length of 5. Let's match up on our pink lines here. The smaller triangle has a length of 3, and the equivalent one on this other triangle, let's call it x. We don't know what that is. That's the one we want to figure out. Okay, we've got our ratio set up as two ratios set up as a proportion. Now we're going to cross multiply to help us get to solving. So we're going to say on our left side we've got 2 times x is 2x. And of course it wouldn't matter which side of the equal sign these ended up on. And 3 times 5 is 15. So 2x equals 15. Let's divide both sides by 2. So this one divided by 2, the 2 is gone. 15 divided by 2 is 7.5. So it looks like that side will be 7.5. And we'll put a box around it since it's our final answer. Can you do all of that? Can you get to an answer for similar triangles? That's our first one. Here's our next one. We're going to look at primary trig ratios. Good old SOHCAHTOA. So can you identify a right angle triangle? I can identify the hypotenuse, opposite, and adjacent sides from a given angle in that triangle. Can I identify if sine, cos, or tan ratio should be used, knowing sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent? Can I set up a sine, cos, or tan ratio? And then can I solve for the unknown? So sine inverse, cosine inverse, or tan inverse to find an angle if I'm talking about an angle in that particular case. Let's start by having a look at a problem where we're trying to find a side. So I have my little handy dandy reminder up here, and I'm going to need to get myself a little more room here, so let's get rid of that. Extend my page a little bit, and we'll start with our problem on the left where we're finding a side. So we say, okay, first thing I got to do is it a 90-degree angle triangle? Yep, sure is. And I can see that just from the little box right here in the corner. Let's look from our 31-degree angle. That's our angle we're looking at. And I notice that this long side is the hypotenuse because it's always across from the 90-degree angle. Our opposite side is over here. It's opposite the angle. It's on the other side of the triangle, right? All the way over there. And our adjacent side is right here. Now, which ones are important to me? Which ones do I think I'm going to end up using? Well, I know I need to find the A, so that's my adjacent side. So right away I know it's got to be cosine or tangent because they both have adjacent in them. And I know the other one is the hypotenuse right here. Let's do that in a different color actually. Here's my hypotenuse. That's one of the ones I know, so that one is one I'm going to use. So that would mean either sine or cosine. So it looks like cosine is the one because it has both the adjacent side and the hypotenuse. It has the two sides that are useful to us. The opposite side, we don't know it and we don't need to know it, so it's not useful to us. So that one's not one we're going to use. So we're going to use a cosine ratio to solve this. So I'm going to set up my ratio by saying the cosine, and I always have to put an angle with the cosine, whether it's a known or an unknown angle, the angle has to be there. Cosine is adjacent side, that's A in this case, over hypotenuse, that's 16, so A over 16. Okay, let's do some solving with this. I'm going to treat this like it's a proportion, so I can put that over 1. Let's cross multiply. So A times 1 is just A, and 16 times cos of 31 is 16 cos 31 degrees. Now cos of 31 degrees is just a number, right? If you plug that into your calculator, you get a like a decimal number. So I'm not going to change cos of 31 into a decimal number, but it is. So you should plug that into your calculator. If you want to turn it into a decimal first by using the trig table or your calculator, that's fine. You should go for it. So I'm going to multiply those two together, and I'm going to get 13.7. So make sure you can get that answer. Make sure you can get to 13.7. That's my side length. Now let's try my other one here. I am looking at a ladder against a wall, and I want to know the angle that the ladder makes with the wall. So let's do a little labeling on our triangle here. The angle I'm looking from is that x angle there, the unknown. The opposite side is over here. The hypotenuse is this long side, of course, crossing the 90-degree angle, and my adjacent side is right here. Looks to me like adjacent is not useful. It's not one I know or want to know. Whereas there are two other angles that are more useful to me because I know them. I know the hypotenuse and I know the opposite. So which one is useful for finding hypotenuse, is useful for involving hypotenuse and opposite? Hypotenuse and opposite. Aha, that's a sine ratio, is hypotenuse and opposite. So I'm going to say, okay, sine of my angle. And in this case, it's angle x. Usually we use theta. Is the symbol, looks like this. We use that to represent an angle, but x could be one as well. X works just fine. So we're going to say, okay, sine of that angle, that unknown angle, is the opposite side over the hypotenuse. The opposite is 2.5. The hypotenuse is 5. Now you might be able to look at that and just say, oh, that equals 0.5. And yeah, you'd be right. But if you can keep this in your calculator, for other ones it'll be easier when you're doing it. We're going to do the sine inverse, right? That's the only way we can break these apart is by doing the inverse. So I'm going to do the sine inverse. Now you could just write 0.5 in here because we know 2.5 divided by 5 is 0.5. But I'm actually going to type into my calculator the whole thing like that, 2.5 divided by 5, and I'm going to close the brackets. Make sure that's all in brackets because if I had one that had more complex numbers, I wouldn't actually have to divide them and find the ratio. The calculator would do it for me. Okay, so what's that work out to? You should be able to find out that works out to exactly 30 degrees. But since I'm going to write it to one decimal place, I'll write it as 30.0 degrees. Okay, make sure that you can get that same answer as well. Moving on, let's talk about sine law. So I can identify a known side angle pair where I know both of them. Identify another side angle pair with one unknown. Set two ratios equal to one another to form a proportion, solve for the unknown, and use the inverse sine if you need to find an angle. Of course, this only sine law is one we're using where we're looking at a non-right angle triangle. There's no 90-degree angle in the triangle, or we're not sure if it's a right angle triangle. You could use sine law to solve for a right angle, stuff in a right angle triangle, but it's a waste of your time because it's much easier and faster to just use basic trig, SOHCAHTOA. So you can use sine law for that. It wouldn't give you a wrong answer, but it would waste time. You wouldn't be as quick. Okay, let's look at our first one here. We're trying to find the length of side C. So let's use our highlighter here to try and find some things. First, we want to find a known side angle pair, where we know an angle and we know the side that's opposite and across from it there. It looks like we don't have a known side angle pair, right? Because I know this angle, but I don't know this side right here. I know this side right here, but I don't know this angle right here. So we don't have a side angle pair. But I notice that I actually have two of the three angles in the triangle. And that would allow me to find the third angle. So let's do that first. Let's start by finding that third angle in the triangle. So I'm going to say angle A, the unknown angle, is 180 degrees, the total in the triangle, minus the other two sides. Whatever's left over is going to be angle A. So angle A is going to be, what is that, 78 degrees. Okay, so I'm actually going to write that in there, 78 degrees. That's my angle A. Good to know. Now we have that matching side angle pair, and we can go ahead. So I know this side. I know this angle. That makes a known side angle pair where I know both of them. Now I need to find a side angle pair where I know one of the two, and the other one is the unknown that I want. Well, here's the unknown that I want, and here's a known angle, so that makes a side angle pair where I know one of the two. But the other one is going to be my unknown. That's great. So I'm going to be able to solve for my unknown. Here we go. Let's set up our proportion. Let's start with the one that we know. Now you could start with either. It doesn't matter which side you put them on. But let's start with the known side angle pair. I'm going to put the 7 on top. And on the bottom, I can't just write 78. I have to remember it's got to be sine of 78, or this won't work. I cannot just put the angle. And that angle goes with sine. You never put a side in with sine. Sine, cosine, tan have to go with angles. Now let's do the one we want to know. We want to know C, and the matching angle for that, we'd say sine of 39 degrees. Okay, so we've set up our proportion. Let's do that cross multiply game. What are we going to end up with? Okay, we're going to have on the on one side, let me just get myself a little more room here. On one side, we're going to have 7 times sine of 39. So we'll say 7 times sine of 39. 7 is just a number. Sine of 39 is just a number. And then we've got our C, our unknown, times sine of 78 degrees. How do we get C by itself? Because it's the one we want to know. Divide both sides by sine of 78. It'll be gone from here, and it'll end up down here. So we end up with 7 times sine of 39 degrees over sine of 78 degrees. That's calculator work. 7 times whatever sine of 39 is, that's a decimal number, divided by whatever sine of 78 is, that's a decimal number. You should end up with a, when you round it to one decimal place, 4.5. So try that out. Make sure you can do that on your calculator and that it matches. That's finding a side. How about when we want to find an angle in a triangle? Okay, so it says right here we want to find angle C. That's right here. What's angle C? I don't know. So let's see if we have our matching side angle pair. That would tell me that I'm working with sine law. So here's a known angle and here's a known side across from it, right? They got to be across the triangle from one another. That's a known side angle pair. Here's my unknown one. I know the side 6, but I don't know angle C, so that's my unknown one. That's my side angle pair where I know one of them, and I don't know the other one. Now usually I like to have the unknown written on the top of the proportion. It would be fine to write it with the unknown on the bottom of the proportion. It's totally up to you, but when you start doing this a bit faster, it's easier to solve if you have the unknown on top. So I'm going to write the angles on top. I'm going to do my known one first. I know sine 77. And I know that matches up with 9. I don't know sine of C, but I want to find C, and that matches up with 6. Okay, let's do our good old cross multiply and let's see what we're going to end up with. On the left side, I'm going to have 6 times sine of 77. And again, it wouldn't matter if I put that on the left side or the right side, but it's always going to be 6 times 77. And the other side is going to be 9 times sine c. How do I get c by itself? Well, it's being multiplied by 9. Let's divide both sides by 9. So I end up with sine c equals 6 times sine of 77 degrees over 9. Now, you might be tempted to say, now divide both sides by sine. But sine isn't a thing on its own. You can't divide both sides just by sine. You've got to have sine of an angle. That's the only way it's a thing. You can't just divide by sine on its own because that doesn't mean anything. So really, I need to just do this math. So let's go 6 times sine of 77 divided by 9. I'm going to end up with a decimal number, 0.6496 equals sine of c. Now, since I want to find an angle, I should have known I would had to do an inverse sine, right? So that's what I'm going to do. I'm going to say c is sine inverse. That's the only way I can break those apart, is I'm going to say, okay, what gets me back to my angle? 0.6496. So let's do that in our calculator. What are we going to end up with? We should end up with an angle, and that angle, rounded to 1 decimal place, is going to be 40.5 degrees. So make sure you can do that with your calculator as well. Okay? So I always know I'm going to end up doing the sine inverse when I'm trying to find an angle using sine law. Next, let's go to cosine law. So I can identify that I have a side angle side triangle or a side 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 triangle. What is that? Well, I'll show you that in a minute if you don't remember. I can choose an appropriate form of cosine law, either the form when I'm solving for an angle or the form when I'm solving for a side. I can substitute the correct sides and angles into the formula, and I can solve for the unknown by either taking the square root of both sides or taking the inverse cosine if I'm looking to find an angle. Now, my first one here is, you'll see right here, side, side, side. Side angle side. So that's literally SAS means side angle side. So that literally means in that order. Okay, so I've got a known side. And then in between, I've got a known angle, that's angle A, and then I've got another known side. And I can use those to find this side over here, lowercase a. Okay, so that's my first situation. If I know two sides and I know the angle in between, I can use cosine law to find the side that is opposite that angle. That's my first setup. My other one where I can use cosine law is side, side, side. If I know all three sides, I know this side, I know this side, I know this side, I know all three. Okay, if I know all three, I can use those to find any angle I want. So those are my two situations where I'm going to use cosine law, and I should look for those. Let's try a couple of them out. Here's our first one. We're going to try and find a side here. Okay, we're going to try and find a side. So I'll get out my pen and I'll say, okay, looks like we've got actually let's use the highlighter. Looks like we've got a side angle side situation where I know two sides and the angle in between them. That's great. Okay, that'll allow me to find this side over here. Side B, that's the one I'm going to try and find. So when I set this up, what am I going to do? I'm going to use my cosine law, and I'm going to write it out like this. I'm going to say the side that I want to know, I'm going to write that squared. Looks kind of like Pythagorean theorem when we do it. And then I'm going to write the two other sides. They're also going to be squared. And then I'm going to go minus 2 times the two other sides again, those same ones, times cos of, now it's got to be cos of the angle that's across from the side you're trying to find, right? Those always match up. So we say, okay, right here and right over there are going to be across from one another in the triangle. Okay, so let's actually put that in. We're going to put in 54 degrees. Now I got to put in those two other sides that I know. They could go in any order. I could go 3 first and then 5, or 5 and then 3. Doesn't matter. I'm going to go 5 and then 3, and then 5 and then 3. Okay, and now I'm going to get rid of this underline here just to make it nice and clear. All right, let's continue. Let's actually do the math here. I remember that lots of students, right, I mentioned this to you in class, get stuck because they don't follow order of operations. They don't realize that all this is one term, and they need to deal with that term first before they can do anything else. They have to go 2 times 5 times 3 times cos of 54 before they do any subtracting, or they're going to run into trouble. So order of operations we really need to follow here. Let's do our order of operations. First, we're going to do our exponents. 5 squared is 25. 3 squared is 9. And then I have minus 2 times 5 times 3 times cos of 54 degrees. Now I've got to get this last term in order. So I got 25 plus 9, and then I've got to subtract. Well, what's 2 times 5 times 3 times cos of 54? Well, I could write that out first. 2 times 5 times 3 is 30. And then I have to multiply 30 times cos of 54. That all works out to 17.63. I'm going to write it to 2 decimal places for now, because that's pretty good. And then I'll round off my final answer to 1 decimal place. Okay, and now I'll go b squared. Let's do all the adding and subtracting. We're going to end up with 16.37. Now we've got to take the square root of both sides. So b squared equals that. B equals the square root of 16.37. I'm going to figure out what that is, and I'm just going to go to 1 decimal place. So that would be 4.0 if I go to 1 decimal place. And that's my final answer, so I'll put a box around it. That's finding a side. Let's find an angle. In this next one, we're doing sine law, and I can tell it's sine law because I know all 3 sides on the triangle. Side, side, side. So it's a side, side, side problem. I know all 3 sides on that triangle. So here we go. Let's figure this out. I'm going to use the other version of cosine law because I'm finding an angle. I'm finding this angle right here, angle Q. So I'm going to say cosine of Q is equal to, now it's really important here that I put them in the correct order. I'm going to have a 2 on the bottom, and I'm going to have 2 of the sides, and I'm going to have 2 of the sides squared here, and then I'm going to be subtracting 1 of the sides squared. Which one am I subtracting? Well, it's always going to be the side that's across from the angle you're trying to find. So the 11 has to go here. If you don't put the 11 there, it's not going to work out correctly. The other 2 sides I've got are the 5 and the 12. So I'll go 5 and 12, and I'll go 5 and 12. Okay, so the 2 sides that aren't across from my angle appear twice. The one that is across from my angle is paired up with my angle is the one that gets subtracted. I got to make sure I can set it up that way. If I set it up that way, it'll work out every time. So let's do our math here. We're going to say cosine of Q. Now I know it's cosine of Q, so I should end up with a ratio here. When I work all this out, it should be some decimal number. So I'm going to say 5 squared is 25, 12 squared is 144, 11 squared is, 121, and then that's all over 2 times 5 times 12, which is 120. So I add up the stuff on the top, and then I divide by 120. I'm going to end up with the following decimal. Cosine of angle Q is going to be 0.4. Now normally I'd write a ratio to 4 decimal places. This is exactly 0.4 it works out to. So I could write it like this and keep my ratio to 4 decimal places, or I could just write it as 0.4. Either of those is okay. Now we're not quite there yet. If we want to find the angle Q, we need to take the cosine inverse of 0.4. What's that work out to? That works out to an angle of 66.4 degrees if I round off to 1 to the nearest tenth, to 1 decimal place. There we go. Okay, we've solved for an angle. Okay, last but not least, we're going to have a look at problem solving. So solving more complex problems. This could be similar triangles, this could be SOHCAHTOA, this could be sine law, this could be cos law. It could be any of those 4 situations we've already covered. Okay, we're going to start by looking at our rounding rules. So we're going to round sides and angles. Oh, I wrote sides twice, but it should say sides and angles. Round angles to both of them to 1 decimal place in your final answers, but only round your final answers. Don't round too early, or you can throw your answers off. Now here's our problem solving process. First thing is just draw a picture. If you make a good attempt at drawing a picture, even if it's like not quite right, you're still going to get some of the marks. So always try your best to just draw a picture. Even if you're not totally sure it's right, draw a picture. Next, you're going to state which law or method you're going to use. Is it similar triangles? Is it SOHCAHTOA? Is it sine law? Is it cos law? You're going to make it clear which one you're going to use. And you're right, set up your equation or your proportion, whatever you're using to solve it. And then you're going to solve, you're going to put a box around your final answer, and then you're going to give a nice therefore statement. Okay, that's how we do a nice, clearly communicated answer. You can do a lot of this without even getting the right answer. So you can get a lot of the marks on a problem like this without even getting to a correct final answer by showing you understand the process, this problem-solving process. Okay, so when we're doing problem solving, here's an example. I'm going to go through an example of problem solving, and then we'll end the video there. Two buildings are 26.3 meters apart. From the top of the shorter building, the angle of elevation to the top of the taller building is 53.9 degrees, and the angle of depression to the base of the taller building is 54.7 degrees. What's the height of the taller building? First thing we're going to do is we're going to draw a picture. Now this already came with one, but I would draw a picture that looks like this. I would draw the distance between the buildings, I would draw a shorter building and a taller building, and I would draw the angles of elevation and depression showing how they go to that other building. Now I need to decide what I'm going to use to solve this. Well, I'm going to use, in this case, because I have right angle triangles, I'm going to make the assumption that my buildings are not at weird angles, because the question didn't say anything about that these are both right angle triangles, and so I'm going to use my basic trig ratios, SOHCAHTOA. So I'll write SOHCAHTOA up here just so I can remember that I'm going to use that, and that can help me. Now, if I was a teacher marking this, I would say diagram, check mark, understands its basic trig ratios, check mark, check mark. You already got 2 marks on the question. You already are really on your way. Okay, so let's look at our top triangle here. Actually, let's do our bottom one first. So this angle right here, 54.7 degrees. Let's label our triangle. This is going to be our hypotenuse. Our adjacent side is right here. It's adjacent to the angle, and our opposite side is way over here, opposite our known angle. Okay? Now I'm going to say, well, which am I going to use? Well, my adjacent side, I actually know. It's right down here. It's 26.3 meters. So that's a known side. So I'm going to use the one that I know. And what's the one that I want to find in this case? I want the opposite side, right? Hypotenuse I don't care about. It's not useful to me. So opposite and adjacent, opposite, opposite, adjacent, adjacent. Looks like it's tangent. Tangent is opposite and adjacent. So I'm going to use my tangent ratio to solve this. So I'll say, okay, tangent of 54.7 degrees is the opposite side. We're going to call that B in our diagram. Over the adjacent side, that's 26.3 meters. Now if I do my cross multiply, I'm going to end up, I'm going to say like that's over 1, do my cross multiply. 1 times B is B. That's not 2.63, that's 26.3. 26.3 times tan of 54.7 degrees. I got to plug that into my calculator, and I'm going to end up with 37.14. I'm not going to go to 1 decimal place yet because I'm going to need to add those numbers together. So that's that one. Let's do now A. A is going to be up here. It's exactly the same math, my adjacent and my opposite sides. So I'm going to say it's another tangent ratio of 35.9 equals my opposite side, which is A, over my adjacent side, which is 26.3. Do my cross multiply. The math ends up exactly the same. So I'm not going to take you through all the math. I'm just going to go right to an answer of 19.04. And you might ask, could I do that on a test? Yeah, if you showed me here, you understand all the steps, and then you did the exact same calculation and just skipped a couple of the steps because you already know how to do it, and you feel very confident in what you're doing, then that's fine. If you're not so sure that it's going right, I would show the work just in case because I love giving part marks, right? So now let's add these two together. We're going to see what they are. So A plus B equals 37.14 plus 19.04. I'm going to round this answer to 1 decimal place, 56.2 meters. So now I need to do the therefore statement because this is a word problem, right? So I got to show I understand the context. So we say therefore the height of the building is 56.2 meters. and let's put a box around that final answer, and I got a nice therefore statement. Okay, so I've solved this problem clearly by making a picture, showing I know what kind of math I'm using, showing all of my steps, getting a final answer, putting the box around it, and a nice therefore statement at the end. So this is all that you're going to see on your upcoming unit test. I hope this has helped you feel ready for tackling this unit of trigonometry.